Hello, everyone. Welcome to GCP Online Meetup number 19. I am your host, Jonathan Cham, and we have our lovely guest today here, Patrick. Patrick, how are you?
Good. Thank you for having me.
Oh, yeah, I'm super excited about this. I think this is a wonderful topic that everyone always asks about. If you are new to GCP Online Meetup, welcome. This is an informal, casual, informative discussion. You can just interact with us and have some meaningful discussions around the topics that we cover almost on a weekly basis. Also, if you can hear us well, let us know on the YouTube chat. Really appreciate it. Today, we are talking about AWS and GCP. What an amazing topic. I think in the back of everyone's minds, this is what people think about, right, Patrick?
Yes, absolutely.
Yeah.
And I think this is going to be one of the first series. And I think introducing GCP services in comparison to AWS. And I think one of the best way to start the series is with networking.
Yeah, that's perfect. And if you don't know, I mean, Patrick is a certified architect. He's previously worked at AWS, both sides as a provider and client. So he definitely knows a lot about AWS and obviously GCP as well. So we always welcome any of you viewers and listeners who are very well, in tune with all the AWS offerings. Let us know if you see something that you think is maybe a little bit off or inaccurate. We're always looking for information that makes this information better.
Yeah, definitely, because lots of there's constantly updates, changes that's happening on either of the sides of the platforms. So yeah, absolutely.
Yeah, notice that I had to put July 20th because I might actually even put the time 11:17 a.m. because in about an hour there might be additional announcements on both sides, so it just changes so quickly. You know what I mean? But yeah, let's go ahead, Patrick.
Okay, great.
Let's get started.
So first, I would like to point out that all information that I'm gonna talk about today in the slides is all publicly available. So either you can find this information on the AWS sites, or you can find it on Google blogs and various forums. Um, Also, I would like to note that due to the time, we'll be answering questions, preferably at the end of the webinar, so we get through all the material that we have that I've prepared.
I like to tell Patrick that all we did here was just Google search everything for you guys. I mean, all this is public information, so we're just consolidating all of this for you to make it easier to consume.
That's right. Okay, great. Let's look at the agenda. So we're going to talk about, we're going to look at regions, availability zones, undersea cable projects, VPCs, DNS, load balancers, CDN, private connections, and finally, how to connect both platforms to get most out of the cloud. And during the process, you're gonna find out there's a cons and pros to either of the platforms. So let's look at the infrastructure. Uh, the one thing, you're gonna notice that Google makes lots of various statements. Yeah, like analyst puts its traffic at about 25 to 40% of global internet user traffic. 98% of the time, we hand off packets directly to the end users' ISPs, and global network presence is in 182 countries. UN has 193 member states. So what does it all mean? So when we go to the regions, when we look at regions today, we're gonna, the one thing you're gonna notice today, GCP has 10 regions versus 15 on AWS. And also when it comes to availability zones, GCP has 30 versus 42. Regions in the future. So what we are looking at, the first thing I want to point out that Google it's invested close to $30 billion basically in the past 3 years, and to Google's infrastructure, which benefits Google Cloud directly. Yeah. Keep in mind that the environment we utilize is the same infrastructure as the search, YouTube, G Suite, and other apps and services provided by Google. By end of this year or latest Q1 2018, the number of regions and zones will be pretty much close. Uh, we ending this year. We're going to add about 8 new regions, and AWS is also adding new regions. They're going to be adding 3 new. And so once all that done, but on 2017, early 2018, uh, the the comparison is going to be pretty much the same when it comes to the regions.
So today they have more regions. I think, I mean, AWS has more regions than GCP. I think from a growth perspective, we are launching more regions faster, but we never know what AWS is actually going to deploy or launching.
Correct. There we have a little recap. We can go to the next slide. So we look at it now. Let's go look at networking, VPC, DNS, load balancers, dedicated networks. Number of you might have already seen this map or similar. Here's a Google's global network, hundreds of thousands of miles of fiber, over 100 edge POPs, and present on over 90 internet exchanges. So really, what does it mean? Especially those swirly lines that we see around the continents. So
Yeah.
let's go look at the projects, the submarine projects. Today, so recently there was a faster. Faster is between US, West Coast, and Japan. It has capability to transmit up to 60 terabytes of data per second. In other words, you also have about 10 million times faster than your cable modem. There's another cable project, PLCN, Pacific Light Cable Network, which is between Los Angeles and Hong Kong. Almost 8 miles of fiber optics that can transmit up to 120 terabytes per second, double the transmission and faster. This is equivalent to 80 million concurrent high-definition video calls. Both faster and PLCN are already in service. One of the latest projects, which is basically the 7th investment of subsea cable for Google, is going to have a capability of handling 8 million Google Hangout video calls at once. And this one's going to be between Singapore and Australia. Next slide is going to show us basically the summary of undersea cable projects. Here you see total 7, but there's actually 8. There's one that is not listed. But that's where Google has. So right now we already have 6 in place, 2 of them and 2 of them is being worked on. So now let's look at what about Amazon. So Amazon submarine projects, the first one was announced at 2016 reInvent this past year. It's going to be between US, Australia, and Zealand. I did not come across any specific details about this project at the time I was looking across the various projects.
Yeah, so it's pretty clear that, I mean, all cloud providers are continuing to grow their scope and scale of fiber underneath the ocean. I mean, obviously with Google, because we have almost 2 billion users on our apps, we have to grow much faster than some of these cloud providers. But I mean, overall, I think every cloud provider is growing very quickly the amount of bandwidth that they can support across regions and across geographies.
Yep, absolutely. Now, I just did here. I just want to quickly show. I basically launched instances in the different regions on GCP. It's just one virtual CPU, 1 gigabyte of RAM, and SSD disk with 100 gigs on it, and OS was Ubuntu. So I launched exactly the same in all these 3 different regions. So I was curious myself as well. What is today? If I do just a ping, what is the round trip? Yeah, and here you can see when you look at between Virginia and Oregon, which is East Coast, West Coast, US, you get an average about 59 milliseconds. When you look at between Virginia and London, which is US East Coast, and EU West, you get about 76 milliseconds. And also, I did between the West Coast, the US West Coast, and Singapore for Southeast Asia, and here you get about 162 milliseconds.
Yeah, I think one of the most common questions I get from customers is how does the latency compare, right? And I think AWS would tell you the same thing, and we're going to tell you the same thing. You just got to test it. I mean,
absolutely. Do you own benchmarks? I also noticed there's blogs online that kind of have inaccurate testing, the way they set it up. They, for example, test between UK and East Coast for AWS, and they test between UK and central US. Speed of light only travels, fast as it can.
Yeah, and there's actually a lot of resources out there where they have, I think, long-running VMs on both AWS and GCP that allow you to just do simple ping tests. And I think you can leverage those resources. You can just do a quick Google search. There's a lot of VMs out there that are just sitting there that allow you to do latency testing. That's usually my suggestion to customers when it comes to what is the latency between different geographies and different compute resources within the different cloud providers.
Great. We can skip the summary and recap and go to
the good stuff. Yeah, here we go. This is the good stuff. All right. So here we're going to start comparing actual features within some of the platform products that we have
for the networking services. Right. So let's go look at the VPC. So the one thing that you're going to notice is when it comes to GCP, subnets can span regions versus subnets are constrained to one region on AWS. Same thing when it comes to we have native cross-region connectivity between regions on AWS. You're gonna need a VPN. Or the other thing worth pointing out is, for example, VPC peering. VPC peering here connects. Sorry, here I'm looking. So basically, the VPC peer can peer VPC networks across regions. So neither AWS VPC peering or Azure VNet peering allow creating a VPC peering connections across regions. Let's move to the next one.
I think one comment I want to make is probably, a lot, even though there might seem to be some gaps. There's always third parties that, third party maybe software and other workarounds that you can bridge, on some of these gaps, being constrained to one region. I'm sure there's something that you can do to kind of address some of the limitations.
Absolutely. And one of the things also on the VPC, when it comes to a VPN, on GCP, it supports ECMP, and AWS doesn't. And I a little bit going to talk about it more on the next slide over here.
I think this is the one, when it comes to ECMP, that there's actually third parties that can address this limitation, right? Yeah. So
basically, if you're running a VPN on AWS, they don't have a way to load balance on multiple tunnels. In our case, we support equal cost multipath. But to accomplish the same thing, you can use like OpenSpan or something with on AWS with AWS basically to get the same feature.
Mm-hmm. So basically, GCP, we have this out of the box. With AWS, you can add a third-party software tool to enable this.
Correct. Okay. Let's look at next. Let's look at the DNS here. So it's a little bit, when it comes to DNS solution versus AWS, it's so AWS has Route 53. We have Cloud DNS. What I would like to point out here, looking at the slide, there is a latency-based routing and geography-based routing. The difference here is that the one thing on a GCP is basically your entire app is available via single global IP address, resulting in simplified DNS setup, meaning we distribute your load balance compute resources in multiple regions, which are close to your users. In contrast, and in contrast to DNS-based global load balancing solutions, cloud load balancing reacts instantaneously to changes in user traffic network, etc. So basically, what here we don't with the DNS solution, the cloud DNS, the latency-based routing is actually done through our load balancers because we're using the any cast IP. Same thing with the geography-based routing. We send the traffic the closest to you, but also you can constrain to which region.
So with the Anycast IP, it basically makes it a little bit easier to manage your workloads because it is just routing it for you to the nearest workload with the lowest latency.
Correct, and again it's a kind of the comparison here is exactly. So that's why the comparison here between like Cloud DNS and Route 53 doesn't is not that straightforward.
And that's why there's all these asterisks.
Yes.
Okay, so we don't have, GCP doesn't have global private zones. Amazon does.
Yep.
Okay.
And the either one doesn't have DNS forwarding or DNSSEC.
And so for DNS forwarding, I guess, both users of AWS and GCP would probably use a third-party provider for that.
Correct. Yeah. And for DNSSEC, Amazon supports it for domain registration, but not for the DNSSEC for DNS service.
Right. So load balancing.
Let's go look at the load balancer here. So on GCP, we call it cloud load balancing. AWS, it's elastic load balancers. The main difference is here, when you look at GCP, it's software defined versus having virtual machines for basically VMs for your load balancers on AWS. When it comes this to play is when it comes to preforming. If you have suddenly a big spike of traffic, you might start seeing a latency and not able to reach services on the back end. So with Google load balancers, you really don't have to worry about it because no preform is required. So you don't have to submit any forms, notify Google, hey, we're gonna be spinning up, we expect more traffic, please, preform for us.
Yeah.
The one thing I do want to point out for AWS load balancers, they support layer 4 and 7 both under public and private load balancers. On GCP, you only get layer 4 and 7 at public, but not at private.
Yep.
The both support content-based routing, and importantly, as more and more businesses are moving towards containerization, they both support container-based applications.
I think we're talking about this. I think AWS has a slightly better wildcard feature for application or content-based routing, right?
Yeah. The way you do your role, like when you do the content-based routing for GCP, you can only put your wildcard at the end, while in the path for ELB, you can actually put it within the path as it fits your environment. So it's more flexibility.
Yep. All right, CDN. This is my least favorite slide, but it's okay. This is supposed to be very unbiased, and I mean, I'm really glad Patrik, took it to heart to make it. This is all factual, right? I think one thing to keep in mind is actually a lot of our technologies are built from kind of what we had internally over the last 10 years running our internal cloud. And once we expose what we needed to the public, it's very easy and quickly that we realize that customers need a lot more than just what Google needs. So, Patrik, maybe you can talk about where we compare here.
Yeah. So the one thing when it comes to a CDN, or CDN is also the one thing to point out on AWS. When you're utilizing CDN, you actually have to create distribution. On GCP, you just basically it's integrated with the load balancer. So as you can see, like when it comes to the specific DNS services or features or CDN, it's all integrated with basically with all load balancing. Or I should say many of the features. But here specifically, the origin of content, you get the same. It's your object storage, your VMs, your load balancing on either side. The one thing, or few of the other things to point out, additionally to do the origin with AWS, you can do external custom. They both invalidate multiple objects. As for GZIP compression, done it on AWS, not on GCP. Let's go to the next slide. That is still CDN.
Sure.
And as on the continue side for CDN, again, when we look at it, like video streaming, we're not doing today. It's done through AWS, but it's done on AWS. Again, the one thing to point out here, we use what cannot be done directly through GCP. In this case, the CDN lacks of features versus CloudFront. In that case, again, we have third-party partners that fill out these gaps for us.
Yeah, I think for the most part, for a CDN, the Google Cloud Platform CDN is very basic. I mean, it's very good, but it doesn't have all the great features. So a lot of the times we work with partners like Akamai, Fastly. I mean, you name all the big CDN providers, we partner with them. And on top of that, we allow, or we will discount egress traffic if you work with some of the CDN partners. So usually we bridge a lot of these gaps with partners. But again, as Patrik mentioned, AWS, their out of the box CDN definitely has more features than the Google Cloud Platform. Yep. Dedicated network connections.
Let's look at dedicated network. Okay, so a couple of things to look at. So AWS has direct connect, or you do a direct connect with partner, meaning go through a third party. Basically, you can set up layer 2, VLANs or IP. They both allow for private addressing. And so direct connect is equal to private interconnect on GCP. And direct connect with partner is basically equal to partner interconnect. The one thing to note is when you're doing direct connect, you do either directly with AWS, you either have 1 or 10 gigabits per second connections. For GCP, it starts at 10 gigabytes per second connections if you're doing directly with Google. In that case, if you want lower, you have to go through a partner, And same thing for AWS. So with AWS, anything under 1 gigabits per second, you go with a partner. For Google, anything below 10 gigabits per second, you have to go with partners again. And either of the, if it's AWS, GCP, they use level 3 or AT&T partners and others.
So Patrik, just to check myself, what would be the layer 3 direct connect for Google Cloud Platform? Is that the partner?
Yeah, you would go through the partner.
Okay, yeah. So yeah, I think we were talking about this earlier. Even though there's less rows in the AWS box, it's actually what you would say.
It's pretty much equivalent.
It's pretty much equivalent. It's just how we've structured these different network connections. But yeah, ultimately, it's pretty much feature parity.
Yeah. But as the technology on the back end and stuff like that, that's where it would vary. And the one thing I would like to point out is that with Google, you can connect. You can do a interconnect with Google, say in Sunnyvale, and this way you can connect to all other regions due to the backbone, Google's backbone versus AWS. It has to be interconnected at every region. The caveat to there, we do charge for egress to other regions, but also QoS traffic between regions goes through Google. So we prioritize the traffic. AWS traffic is going through transit providers, so AWS has no control over prioritization. So that's something to point out.
Yeah, and another thing that many people didn't realize was that AWS and GCP actually exist in many of the colos, they exist in the same ones. And so when a customer says, what is the latency between the two? I mean, it could almost be negligible just by the fact that both AWS and GCP have such a large presence in many of the colos and pops.
Yep. And this is going to bring us to the next final slide.
Oh, see, I beat you to it.
So here, I wanted to basically kind of tie together the both platforms. Yeah, we see today. If you would talk to customers 3-4 years ago, it was like which cloud customer is going to choose. Today, there's many businesses already running on the cloud, and today it's more the conversational or basically heading towards how we want the multi-clouds. Yeah, multi-cloud strategy. And why is that? The main reason behind it, the drivers that we see is each, when it comes to the different platforms out there, each one always have their strengths and weaknesses. And basically, what customers are doing is balancing it. And what Jonathan pointed out, like in here, I'm showing basically you can do a dedicated network. You can connect GCP platform, AWS platform to a core data center like Equinix, and basically connect it to either customer or partner router in their cage, and there you go. So our customers doing it, absolutely.
Yeah. What customers usually do is, I mean, I think there's kind of like a threshold for when it makes sense to do multi-cloud. I think for really large businesses that have, billion-dollar businesses that don't want to only use one cloud. I mean, for many reasons, right? Number one is high availability, just in case one of the clouds, something happens, they'll actually have another cloud that can run their production workload. But also, avoiding vendor lock-in.
Yep.
So, the bigger business, or the bigger you are as a business, the more resources you have to put in managing multiple clouds. But if you're a small business, you're not going to try to train everyone to learn how to use both clouds, right? It just doesn't make sense.
It doesn't make sense, but I've been seeing, startups and small businesses still going to
Very interesting. Yeah.
So it's I would not say I would say it's pretty much for any size of the business, because again, like with containerization, yeah.
Right.
So that gives you a flexibility to move across clouds. So that's something to consider. So that's what customers want to utilize. And then you have, you look at, say, ML, or you look at big data, again, customers want to utilize the best out of the cloud.
Right.
That's where it's going.
Yeah.
And this is what I kind of want to just show, at the end of the day, you can tie it all together. Yeah.
Yeah, no, this is great. So this is really great. I know that, there might have been some questions in the chat, but I mean, from a high level, I guess what is the next discussion we'll have when it comes to AWS and GCP?
So the next discussion I would like to do is cover compute.
Okay.
There's plenty of services on the compute on each side, and I think that again, it's definitely would be an interesting conversation to have and look across the services.
Yeah, no, that's going to be really interesting. I know. I mean, obviously, compute is kind of the fundamental technology that runs your application, and so with compute, spans a lot of different features and capabilities across both clouds.
Correct.
But let's see, we have 1 minute left. I think Patrik, you've done a tremendous job here.
Thank you.
Right now, I think this is a really good discussion to have with customers, right? I think customers want to understand the differences between AWS, GCP, and other cloud providers, to give them more information about how it's different, right? So there is a question about studying to cloud architect. Are there any plans to cover this kind of subject? So Juliana, I think we can send you a link to our public site about that. I know it is a little off topic, but we can send you a site right now. I think all the content that you can study for, I think we recently announced the certifications for cloud architect and data engineering. I think everything is just on the public site. There's nothing There's actually some Coursera courses that you can look at. So if you just go to Coursera and search Google Cloud, that will actually bring up a set of courses that are tailored to getting certified for Cloud Architect. That's a great question. This is something that we recently announced. So for those of you who are interested in becoming more proficient and getting more experience with Google Cloud Platform, we recently announced certifications around our platform. And it's basically just like any certification that AWS and Microsoft and all the other cloud providers have.
And to the job market, it's very beneficial to have these. So it's a great thing.
No, that's great. All right, well, we're out of time. Thank you so much, and continue to look forward to having everyone join. And thank you, Patrik.
Thank you, everybody.